Okay, so today just examples of covalent bonds and why we sometimes have to put in double and triple bonds and how to go about that process. So first, NBr3. Show me the electron dot diagram of how NBr3 forms. And for right now, I'm going to tell you N is central. Eventually, I'm going to expect you to figure out that N is in the middle, that everything's hooked to N. Okay? So NBr3. So my jigsaw puzzle is going to be 1 N and 3 Brs when I'm done. Everybody looked like a noble gas. My pieces are going to be these. A nitrogen, and nitrogen is a group 5A, so it gets 5 dots. 1, 2, 3, 4, 5. They don't pair up until they have to. And Br gets, well, Br is in a halogen, group 7A, so it gets 7 dots. 1, 2, 3, 4, 5, 6, 7. So those are the pieces that I have to build NBr3. Now, if you look at N, does Br3 make sense if you look at N? Okay, because if you look at N, this N has 3 holes that need to be filled. 3 places to make a bond. Okay, everybody see where I can put Brs? I put the N with its 5 dots, and then I hook a Br with its 7 dots. So I put the 5 for N, and now I put the 7 for Br. 1, 2, 3, 4, 5, 6, 7. And when I do that, that Br now has 8 electrons next to it. It looks like a noble gas. But it's not NBr, it's NBr3, so I have to hook on more Brs. Can you see where another Br would hook onto N? Lots of places. 1, 2, 3, 4, 5, 6, 7. And that Br now has 8 because it shared 1 from nitrogen. I have to put Br3. Everybody tell where the third Br is going? At the bottom, yeah, there's not much choice, is there? 1, 2, 3, 4, 5, 6, 7. And we need to check that everybody's got 8. That Br has 8, that Br has 8, that Br has 8. And the N in the middle now has 8. So everybody looks like a noble gas, and I've got the right picture on the box. I'm done. So this is what the structure or structural formula of NBr3 looks like. Now, this is not the real shape. There's really no 90 degrees in it, but we always want to set them up so that we have pairs on top, bottom, left, and right, which is going to force our shapes to be grid-like. We don't want things coming off at strange angles. We want it to be grid-like, right angles for everything. I mean, it didn't matter where I put the Br, or where I could put that Br on top if I left the bottom 2 filled. So, really hard? Hey, so let's try H2CO. Once again, I'm going to tell you that C is central. Central means everything is hooked to it. So my pieces are H with 1 dot. C, group 4A, 4 dots. O, group 6A. 6 dots. Now this jigsaw puzzle is pretty easy. They told me what order to put them together. They told me C is central. So I put in the C with its 4 dots. And then I have to hook on 2 H's and an O. So I stick an H on, an H on, and an O with its 6 dots. 3, 4, 5, 6. There we go. So I built everything they told me. Am I done? Well, the H's are done. The H's are happy. Because with 2 dots, hydrogen looks like helium. So the hydrogens are done. But my carbon only has 7 dots around it. And my oxygen only has 7 dots around it. So those 2 aren't done yet. What do I do? Can I just throw some extra electrons in? Well, I can, but then it wouldn't be neutral. It'd have a charge. I don't want it to have a charge. If it had a charge, they'd put a charge on that, and it doesn't have a charge. So I can't put extra electrons in. I've got to use just the dots I've got. So what can I do? Well, I tried single bonds. Single bonds weren't enough. And if single bonds aren't enough, make more bonds. So I can take this dot and this dot, erase them, and make another bond. When I do that, when I make a double bond, I think that's where I finished off yesterday, a double bond you do when you tried single bonds and it didn't work. Right? We tried single bonds. It didn't work. By sharing more, everybody gets to count those shared. So by moving those 2 in, instead of being 7 and 7, I end up at 8 and 8. That make sense? Okay. So I didn't have any choice. It wasn't my first choice. It was I got all singles, and then I had to make more bonds. Okay. And it doesn't have to get very complicated for those types of things to happen. Yesterday we said oxygen was diatomic. That the air we breathe is oxygen, but the oxygen is O2, not O. How is a molecule of O2 connected? Well, O has 6 dots. The second O has 6 dots. Now I'm going to do it just so that you're not surprised like this. I'm going to draw my 6 dots just slightly differently for no reason other than to show you that it doesn't make a difference where I draw that dot. Okay? It doesn't matter whether this dot is on top, the lone dot is on top or on the bottom, but because these bolts still have a hole, we know we're not done. Everybody can tell that I don't have 4 pairs around my oxygens. So I tried single bonds. That didn't work. So now I need to share more. So I take 1 from each. I take 1 from this one, 1 from that one, and I make a double bond. I still have the same total number of dots I had before. I haven't changed that. I started off with 12 dots. There are still 12 dots on that screen. Okay? But now this oxygen has 8 because it gets to count both of them in the double bond. And this oxygen has 8 because it gets to count both in the double bond. So we try single bonds, and if that doesn't work, we go to multiple bonds. Bless you. So you notice that when I'm drawing the structure, I draw it with the right number of dots every time and then erase dots to move them around. Let's get as nasty as we can get. This is probably the nastiest one I can give you. SO2. So, and it tells you S is central. So I look up S on the periodic table. It's in group 6A, so it gets 6 dots. Look up O on the periodic table. It's also in group 6A. 6 dots. They tell me how I'm supposed to put it together. They tell me S is central. So I know the sulfur, draw in its 6 dots. Then the oxygen with its, now I add 6 more. 1, 2, 3, 4, 5, 6. And then I have to add an oxygen over here with its 1, 2, 3, 4, 5, 6. Are we done? Well, if we look at the sulfur has 8. But the oxygens only have 7. Both of them. So I tried single bonds. It wasn't enough. Yeah. So I got to try multiple bonds. I got to make a double bond. But when I go to do that, I run into a slight problem. If I move this dot in to make a double bond, I'd have to take one of these out to make the double bond. But now, my sulfur would have, my oxygen's good now. Now my sulfur has 9. So what do? Well, this oxygen only has 7. So I just take this electron off and move it there. So what really happened when this one came in, it pushed one off over here because it was already full. I couldn't get to 9. So when I put that 9th one in, one of the 8 hops off. So let's go back and see. So that ends up like this. Okay, 1 double bond, 1 single bond. Everybody looks like a noble gas. Sulfur has 8. Oxygens have 8. Let's go back and see how I made that double bond stuff happen. So this is where I was at. The sulfur was full, but I had to make more bonds. So to make more bonds, I moved one of my electrons in. But that's only half the bond, so I have to take one from here. But the electron that I moved in was the 9th one on here. I can't have 9 valence electrons, so this one moved over there. And I ended up with this. That's complicated. But I didn't have any choice about what to do. I tried single bonds. It wasn't enough. So I had to make a double bond, which forced that other dot to move away. There's no other place for me to put that double bond. So the technique we're using is actually called trial and error. With a little bit of planning, but it's trial and error. You try it and see if it works or not. If it doesn't work, try something else. I'll teach you a couple other ways to do this. Okay? But they all end up with the same thing. Everybody's got to look like a noble gas. So I've talked about it a lot.